Quarks and antiquarks. Quarks are fundamental particles. This means they're not made up of anything simpler, as far as we're aware. There are 6 types or flavours of quark, called up, down, strange, charm, top and bottom. But you only need to be aware of the first 3, the up, down and strange quarks. Each has a corresponding antiparticle, such as the anti-up, the anti-charm, and so on. Quarks never exist on their own, only in hadrons, which are made up of combinations of quarks. And there are 3 types of hadron. There are baryons, such as protons and neutrons, and these are made up of 3 quarks. There of course are antibaryons, such as antiprotons and antineutrons, which would be made up of 3 antiquarks. And there are mesons, which are made of a quark-antiquark pair. There are 3 properties of quarks you need to be familiar with. However, you don't need to remember them, as they are quoted on the datasheet. First, charge, which is quoted in terms of the magnitude of the charge on the electron, 1.6 times 10 to the minus 19 coulombs. The down quark and strange quark both have a charge of minus 1/3, whereas the up quark has a charge of plus 2/3. Baryon number, well, they all have a baryon number of 1/3, meaning in a baryon consisting of 3 quarks, it will have a baryon number of 1. Finally, strangeness, well, the up and down quark have 0 strangeness, the strange quark a strangeness of minus 1. Each of these has an associated antiparticle, which has the same magnitude but opposite sign of all these properties. So the anti-down will have a charge of plus 1/3, a baryon number of minus 1/3, and still a strangeness of 0. The anti-up will have a charge of minus 2/3, a baryon number of minus 1/3, and a strangeness of 0. The anti-strange, a charge of plus 1/3, a baryon number of minus 1/3, and a strangeness of plus 1. There are rules relating to the conservation of these properties in particle interactions. This is covered in the video on conservation laws. We'll now look at the makeup of some of the hadrons. There are rules relating to the conservation of these properties during particle interactions. This is covered on a different video. Now to look at the makeup of some hadrons. First the baryons, and here we have a proton, which is made up of 2 up and a down quark. Adding the charges together, we have plus 2/3, plus 2/3, minus 1/3, giving the familiar charge of the proton of plus 1. We have a baryon number of plus 1, because each of the quarks has a baryon number of plus 1/3, so they add to give 1. Ups and downs have a strangeness of 0, and so the proton has a strangeness of 0. Next we have the other familiar baryon, the neutron, and this consists of 2 down and an up quark. So its charge is plus 2/3, minus 1/3, minus 1/3, giving the charge we know of 0. Again we have a baryon number of 1/3, plus 1/3, plus 1/3, so overall it has a baryon number of plus 1, as do all baryons. And again it has a strangeness of 0. Next we have this, which is basically the same as this but made up of antiquarks. It has an anti-up, an anti-up, and an anti-down, so it must be an antiproton. It has the opposite charge of a proton at minus 1, a baryon number of minus 1, but still a strangeness of 0. And the final baryon, the antineutron, consisting of an anti-down, an anti-down, and anti-up. It still has a charge of 0, a baryon number of minus 1, and again a strangeness of 0. So, the proton and neutron are baryons, with a baryon number of +1. The antiproton and antineutron are antibaryons, with a baryon number of -1. And the final type of hadron to look at, the mesons. These consist of a quark-antiquark pair. There are a number of different types of meson, but the only two you need to be aware of are pions and kaons. First we'll look at the pions. These have zero strangeness. There is the pi minus, which is a down anti-up, and as you'll see it has a charge of -1/3, -2/3, therefore a charge of -1. There are the neutral pi noughts, which all consist of a matching quark-antiquark. For instance, an up anti-up, a down anti-down, or a strange anti-strange. In this way the charges cancel out and they have zero charge. Also the pi pluses, which is an up anti-down, so we have a charge of +2/3, +1/3, overall a charge of +1. All these charges are linked to the charge on the electron. The kaons have non-zero strangeness. So we have the K minus, which is a strange anti-up. We have the K naught, which is a down anti-strange. The anti-K naught, which is a strange anti-down. And the K plus, which is an up anti-strange. The line above the letter here is what denotes an antiquark, or indeed this notation is used for any antiparticle. Beta decay can be explained in terms of quarks. In beta minus decay, a neutron becomes a proton due to a down quark changing what's called flavor to become an up quark. An electron and an electron antineutrino are ejected. So, here is our neutron consisting of an up and two down quarks. This down quark can change to an up quark and eject an electron antineutrino and an electron or beta minus particle. In beta plus decay, a proton becomes a neutron due to an up quark changing flavor to become a down quark, and a positron and an electron neutrino are ejected. So here is the proton with two ups and a down quark. This up quark changes into a down, ejecting our positron or beta plus particle and the electron neutrino. You see again we have this notation with the line above representing the antiparticle. Both these decays can be represented on Feynman diagrams. So here we have beta minus decay with the down quark here changing into an up quark and ejecting a W minus boson. That here decays into the beta minus particle and the electron antineutrino. In beta plus decay, the up quark changes here into a down quark, emitting a W plus boson, which here decays into the positron and the electron neutrino. As mesons always consist of a quark with baryon number +1/3 and an antiquark with baryon number -1/3, they always have a baryon number of 0.